Great.
I was like trying to message you all day. Coming to you and pick you up like stop.
Wow.
What's your grade grade fun though? But
Totally.
like
So much fun.
yeah, I had like the
Oh, yes. Oh, man.
That was unfortunate.
Oh, yeah, I
They fart because they can't hold it in.
I didn't.
Yeah.
I need a calculator.
And it's not fun.
Your coat on because
Yeah, I hadn't
Can I
either.
borrow your calculator?
Yeah, you
I'll
can.
when we're
Oh,
at
really?
this meeting.
Awesome.
Great.
I have one that does that. I have like a couple
Yeah,
of
I'm
stuff.
I'm gonna write it. You have to give me the date so I can write it on my phone. So my So I've never been
You can just
sheet
free and they're all going to your house. You're open my house.
Really? I can't. Oh, I just feel it.
Okay.
I just feel a lot of it.
Can you see that? Alright, so on Friday we left off talking about the definitions of different parts of circles. Radius, or radii, chords, diameters, and secants. Does anyone have any questions about those? No? Okay. And so then I asked you to finish the notes over the weekend. Concentric circles are two or more coplanar circles that have the same center. Do you guys have an idea in your mind of what a concentric circle would be? Okay. So it would be like ripples, like of waves, where you have like a smaller circle inside of a larger circle inside of it. Because all of these circles, I mean, if they actually were circles, if I could draw them nicely, all of them would have the same center. Right? So that's what concentric circles are. One circle, basically one circle inside of another circle inside of another circle. When each vertex of a polygon lies on a circle, the polygon is said to be inscribed in the circle, and the circle is circumscribed about the polygon. So if the polygon, if all of the corners of it are on the circle, we would say, like for the first one, we'd say the triangle is inscribed in the circle, or the circle is circumscribed about the triangle, if you should see that. And a sphere is the set of points a given distance from a point. And it's interesting to compare that to the definition of a circle. What's the definition of a circle that you wrote down? What?
The set of points in a plane that are a given distance from a given point in the plane.
So what's the difference between that and the definition of a sphere? Sarah?
Does it have to be in the same plane for a sphere?
Right. So basically, a circle is two-dimensional, right? It's in one plane, but a sphere would be like a ball, right? And so that is three-dimensional, it goes in all directions. So the definition of a sphere and the definition of a circle are very similar. Your book goes on to say that all of those other definitions that we have of radius and diameter and secants and all of that, if we took out the part that said in a plane for all of those definitions, then they would apply to spheres. Alright, let's look at the oral exercises on page 273. For the circle shown, name the center. What's the center? Wolfie? O. The two radii. You guys don't have to write this down, but if you want to, you can. Two radii. Sarah?
CO and OD.
CO and OD. Good. A diameter. Yeah.
CD.
Good. 3 chords. Wolfie?
A, B, C, D, and E, F.
A, B, C, D, and E, F. Good. And a secant. Sarah?
Line B.
Line E, F. Good. I'm glad you said line E, F. So, E, F, the segment is the chord. It's off. Thank you. Go back. Okay. E, F, the segment is a chord where E, F, the line is a secant. Okay? Good. And we're going to do the same thing with the sphere in number 2. So, what is the center of the sphere? Sarah? P. 2 radii. Wolfie?
P, Y, and P, X.
P, Y, and P, X. A diameter. Morgan?
Oh, sorry. YX.
Good. Chords. Yeah.
UV, X, Y, and WZ.
Okay. And a secant. Wolfie?
Line, U, V.
UV. Line UV. Good. Okay, so you can see that pretty much it's the same thing for sphere as it is for circle. One's 2-dimensional, one's 3-dimensional. What would be the diameter of a sphere whose radius is 3? Sarah? 6. What would be the diameter of a sphere whose radius is 8.5? Wolfie?
17.
17. And 12.3? Wolfie?
24.6.
And J? Morgan?
2J.
Good.
It's off again.
What is the problem today? Good? Yeah. If anybody touches like the internet, or I don't know if that has something to do with it or not. State the radius of a circle in which the longest chord has length 12. What is the longest chord of a circle? Sarah? The diameter. So if the diameter is 12, what's the radius? Sarah? 6. If it's 11, Wolfie?
5.5.
5.5. If it's 8.36, Hannah?
4.18.
2J? Hannah?
J.
Or K? Sarah?
K over 2.
K over 2 or 1/2 K? Good. The radius of circle O is 6. What can you say about the length OX if point X lies on the circle? Hannah?
OX is the radius.
Yes. And? Therefore? Sarah?
6.
It's 6. Okay. And it doesn't say 6 what, but so it would be 6. The length would be 6. What if X lies in the interior? What could you say about the length of OX? Wolfie?
It's not 6.
More specifically?
It's less than 6.
Is less than 6, right? And if X lies in the exterior, then Wolfie?
It's more than 6.
It's more than 6. Good. Okay. Sphere R has radius 8. Describe the position of point Y in relation to the sphere. If Ry equals 8, where would be the position of Y?
I have a question.
Yes? Uh-huh.
If it's like on the perimeter of the circle, is that not in the exterior or interior?
Correct.
Okay.
So it could be in one of three places. It can be in the interior, we just say on the circle,
Oh.
or in the exterior. Mhm. So if Ry equals 8, where is point Y? Morgan?
In the center? Or on this perimeter? Diameter? No, circumference.
I think, so they named it sphere R, which means that the center is the R, so Y would be the,
The out, like the not outside or inside.
would be on the sphere, yes,
Yeah.
right. Okay, and if Ry is 10, where would Y be? Wolfie,
Would be out of the sphere.
right? And we call that the,
Exterior.
good? And if Ry is less than 8, Wolfie?
It'd be interior of the sphere.
Good. Okay, I apologize if this is too basic for everyone, just want to make sure we're on the same page, so thank you for those of you who are playing along. 2 points lie in the interior of a circle, but neither is at the center. How many chords contain both points? One. Because there can only be one line through and 2 points, right? And there's a theorem somewhere from chapter 1 that says that in your notes, I believe. How many secants? Would go through? Olby?
One on there.
Also one, right. How many radii? That's a good question. Yeah, because that would contain both. Oh my god, I'm done with this today. Forget that. Because they're both in the interior of the circle, they could be anywhere. I guess it depends on where they are. If they were both like that, they could both be on radius. So that depends. How many diameters could be?
Would it be none because it's interior?
It could also be 0, yes. I mean, but if they were exactly on the right spots, I mean, it could, but it would have to be pretty perfect. Same with the radius. Okay. The radius of a sphere is 20. What can you deduce about the distance x, y if both x and y lie on the sphere? Sarah?
They're both 20 minutes away from the center.
Okay, and so that's true, and so what could you say about x, y? Wolfie?
That they could be 40.
40 would be the,
Oh, that'd be diameter.
yes, no, that's right, but it would be the,
Distance from each other?
Yes.
From
the what distance?
diameter?
That would be the biggest it could be, right? As if it was on the diameter. But what if y was over here? Would it be 40?
No.
What?
No.
No. So it could, 40 would be the greatest distance that they could be, the length, but it could also be less than 40. And, yeah. What if they were both in the interior? What could we say about the distance x, y?
Then it would have to be less than 40.
It would also have to be less than 40, right? Good. What if X lies in the interior and Y lies in the exterior? Wolfie?
20 would be the greatest. Wait. It would still be less than 40.
It could be,
Because it could be
Anything.
like,
right? Because one could be in the interior, one could be like way out here, one could be like, 2 counties away. It doesn't matter. There's not really a lot we can say about that because it could be anything. If one's in the interior and one's in the exterior, we don't know where the one in the exterior is. How many radii can be drawn in a sphere? Yeah?
Is it like infinity?
Yeah. Mm-hmm. Yeah, infinitely many. Can the intersection of a plane and a sphere be a point, a line, a circle, or the empty set? Or all of the above, or none of the above? The intersection of a plane and a sphere. Wolfie?
to be a circle.
It could be a circle.
It could be any.
That's one. It could be a circle. We have a sphere. I don't know if I have any spheres. I do somewhere. My relational geosolids. So if I have a sphere and I have a plane that's cutting through it, it could be a circle that they have in common. Could it be anything else? Sarah?
If it just like touches the top, it could be a point.
Yes? Mm-hmm. Anything else? Maureen?
Could it could be a line, right? It's like, I don't know, like if it goes through it, couldn't that make a line?
If it goes through it just a little bit, well, it wouldn't go, it would have to, if it was a plane, it would go all or none. Because a plane goes infinitely in all directions. So it could just touch the one side, or the top. But other than that, it would have to go all the way through. So I think just a point or a circle would be the two. What else did they ask about? The empty set? Well, not if they intersect. Can't do the empty set. Okay, so what I would like you to do, let's see. For your assignment is 1 through 16. It starts on page 273 and goes to page 274. It's mainly applying the definitions. There it is, if it stays up, who knows, but.
Wait, so we do. Wait, why'd you do that? This is just totally
So you guys have quite a bit of time to get started, probably even finished on that.
I was going. Oh, I remember that thing. I could do it. I had the
We're going to be getting back into some proofs in this chapter. I know you're excited about that.
They updated it. I hope it's good. Do the lines, squares stuff have to be accurate?
Say that again?
Like, does it have to be a perfect circle
Oh.
and a square? Okay,
I mean,
it'd be nice, but.
do your best, but.
How do you make your factors properly?
We're just cleaning up possible before?
Can't be
I don't know. What's my son those
Wait,
Can we do three?
wait,
Yeah, I know, as in.
Because two sides are congruent, it's
you
not that
can't do
hard.
5,
What's that?
because then if it's, because that means it have to go out. And if it's touching the point at the top, you can't touch the point at the bottom if it goes out.
I don't know what I said, it was on the top.
What?
The only one I thought impossible was 6. Yeah,
I
that's the only
think
one I thought.
5. What is it on like 6, like weird size. Like it's not like a perfect 6 size.
It's one that's not, it doesn't have all the same angles and stuff.
My spear it's small, top, and large, and
Wait, I thought you were doing a circle.
yeah.
Oh.
Take to God.
Go up to the top.
How are you deciding to this?
Well, I think it has to be.
It's my sassy chocolate. Because it's not, it was your
actually.
Okay. Yeah.
I don't want to show you on rectangular thing.
5?
Oh, boy, that's a
For
lot.
5? I thought in this definition of isosceles trapezoid was the kind where it's like parallel lines, but then these two sides are like even
It's like I'm drinking
to each
Josh.
other.
Josh
So I
just
thought
thought
that it would just fit inside of the circle. I don't really know how to explain it. Yeah,
As good as I can do.
where it's not a rectangle, but those two sides are
So
one.
like, these ones are up higher and these ones are like the.
Yeah.
Will you explain to me what 6 is?
Yeah, what about
It's not a rectangle, so it's everything else, it's a square.
How do you do four?
Oh, squares,
No.
so,
It's on regular hexagon, so one of the sides are equal.
Yeah,
you had a sheet thing
but
that
if
says,
if the
it's
sides
like
are
a-
equal,
Okay, I'll just.
how would it fit in?
Is that impossible?
I don't know. Possible.
Because that seems like you, because there's the,
I think,
that's what.
If you're standing here at far, and you're like, it's
Yeah,
like,
I love
there's a straight line here, and then it's gonna round this way, so like, it's still a line that goes there, but like right here is smaller than like right here. So in a circle,
Okay, go. We draw.
that is a great circle. You're gonna have like,
Right, do you understand
and
nine?
then like
Draw
right
two
here,
non-parallel
like,
chords.
right here, and right
Well, if you
here.
had you drawn
And so that's gonna make a different
regular.
size line.
And we got one here.
you mean,
So,
So they're non-parallel.
yeah.
oh, you just make a hexagon but not make them, not make them equal?
Each chord.
Wait, you gotta make one line longer than the others.
Yeah.
Okay, this is the stupidest question I probably ever asked you, but how many sides does a hexagon have again?
6.
No,
Thank
those
you.
are the perpendicular bisections.
But you have 3 quarters. Oh, that's a secret.
Oh, my.
Why do you see that?
I don't know, I haven't been to one.
I don't know, I'm confused. I'm just used.
Yeah. For 6?
Yeah.
Okay.
Can't you just do that?
A non-rectangular condense
Yeah.
parallelogram.
What's the perpendicular
So,
bisector?
And where
You have to go all the way through.
and where do you do?
You can't
do it.
Oh, so
It's in front.
Did you just see me?
That was actually really
what
fun.
happened, babe?
This happened.
Why would?
I'm gonna let go.
Because that has to be touching.
Aw.
That hurt me like a big slapping noise.
It looks like they intersect in between the 2 chords.
Yay. I'm just circling.
Wait for this one, wait, did you get?
You don't want to see that.
Oh, I'm on.
Yeah.
Okay.
You just look like that. Perfect, we have the same thing.
And 8.
Draw a circle and set. And this is parallel chords.
You can just draw a kite for number 8, or, 6.
No, they have,
Number 6, you can draw a kite, because that's not rectangle.
Wait, number 6 is not impossible.
That's
yeah, I still don't get number 6.
Miss
Let's go
Faulkner,
with the
Yeah?
for number 6, could you
Those are big
draw
circles.
a, um,
you know it.
kite, or would that not work?
People probably use it.
A non-rectangular. That means it has to be a parallelogram.
And you're gonna go in square.
Oh, okay.
Yeah.
And
So no.
no.
Wait, so
The
it's
kite. Well, no, kite's not a. Well, it wouldn't touch anyways.
Okay.
So we're really.
Wait for this one.
Okay, 8, so we got the parallel chords. What kind of figure contains
I'm
the
confused on why it's in
midpoints
this.
of the chord?
About what?
Kind of figure? I don't understand.
why you can circle.
Well, I guess,
And
like,
it's
does it have to
anything.
touch the outside?
Yeah.
Okay.
To be like inscribed.
Okay, so
or
it's
whatever.
point here. What did you do for 8?
I don't know, what'd you just say?
So all like the corners?
Yeah.
What kind of figure contains midpoint?
I just
A
drew 2
secant.
chords.
Oh, yeah.
Really?
Well,
I was just
that's
looking at the vocab.
the bisector.
I was so
Who's fine?
Oh.
I want to be a bisector.
Yeah, let's do that. Let's write bisector.
So midpoint
I feel like this entire chapter is gonna be me guessing if I'm right or not.
Yeah. That's probably right.
No,
but it's not right.
it won't be.
But I think
Just
Dora and
with the
her
definition.
better than I am.
Take this off. My arm fits sweat. Yeah. It's not okay. I guess people just want to look.
I don't know, I was waiting for you to finish this on the other side. You could help.
Point,
I
X
said
and
I'm
Y, right, entry of the circle. State the number of points
I think I would go with
in
this.
the intersection of the circle.
I think that
Figure the name.
I'm so confused.
So,
Wait, you guys want mine?
Yeah.
Okay. So I'm 13.
You're on 13. Oh, when's that
show me again.
What's wrong with me?
How did you do this?
Do you want to see my arm?
I don't think I did the
Do you want me to
right,
lift my arm?
Since they're both on it.
and then just be a chord.
So it's like
Did you just have to name that?
But then I got, since these are like.
So when you
Oh,
just be
okay,
chord
so
for one.
segment, ray.
Okay, sure, let's go with that.
Line.
Wait,
Okay, so.
Because they're all on one plane, so
So
the
line
one
is a
line.
segment.
Right,
Just
so
say
it's
like
one segment, right? We're not, and
Wait,
then
I
it's a
just
line,
said
and
the
it's like
just
one
name.
intersection
Just name
of the circle.
But then.
I don't know.
Oh, I got it, so it's 2, 1,
I think we'd
1,
all be one.
0.
Cause it's.
So state the number of points in the intersection of the circle.
Wait,
I
there's
got
none. 0, 1,
oh my god.
Wait.
So what are you doing?
I don't know.
Prop 9, I got
9.
0. Oh, I want 8 and I'm confused about
She
what
said
they're
2
asking.
for that.
I said 0.
0.
She said 0, she said 0.
Oh, that makes
That
sense.
right so
No,
far.
that
That
doesn't
doesn't
make
make
They're both on
sense.
the interior of
Okay.
what? Well, if the line, like if it's a segment, it doesn't mean it's circle.
But if it's on the interior of the circle,
It
there are
doesn't
2
matter.
points on the interior of the circle.
Yeah.
That means the 2 points are in the interior of the circle.
Yeah, so they wouldn't end up with the circle.
This makes sense,
State
yeah,
the
so
number
0.
of points in the
And then
intersection
10
of
would
the
be
circle.
1.
Oh, the,
Eleven
like
is
right here.
Yeah.
This
12
part.
is 2.
Okay.
That makes
Yeah.
sense.
Okay, right, you got 0, and then 10 is 1,
There you go.
and 11 is 1, and 12 is 2, right?
Yep.
Awesome.
Or then 13 through 16, wouldn't they all just be 1? What?
Yeah.
Wait, I'm confused, did you just,
I think
wait.
so.
What did